In the last video, we focused on strings and trying to get a better understanding of how strings work, and we also got some exposure to stuff going on in memory and the stack and the heap and in the constants pool. Now we're going to talk about text file I/O, and this is going to be something that's going to be necessary for your next assignment, your upcoming assignment. And what we're talking about is reading stuff from files and writing stuff to files. And we'll make use of some classes. We'll make use of File, we'll make use of PrintWriter, we'll make use of Scanner again for something different. We've used Scanner obviously for reading from the keyboard, but we haven't used Scanner for reading from a file, so Scanner is a very flexible tool in that way. And so we'll be making use of these as well. So first of all, what's the file class? The file class is a class that we're going to find in the java.io package, which is a package that we'll have to explicitly import. So you've already worked with Scanner and you had to explicitly import the java.util package because Scanner's in that. And for the file and also the PrintWriter, you're going to be making use of this java.io package. So the file class is in that package. We can create an instance of a file and associate it with the name of a file. This would be a file that resides somewhere on disk. And you can either read or write to those files. There's multiple ways to read or write files, and there's multiple kinds of files. We're just going to talk about text files. But there's other kinds of files as well, binary files, for example. And there's also multiple classes that can be used for reading and writing files, but we're going to focus specifically on the PrintWriter class and on the Scanner class. So the PrintWriter class allows writing to an output stream. Now, we've worked with an output stream already. System.out is an output stream. The flow of data to and from files are streams. There's also input streams. And system.in was an input stream. This was a stream from the keyboard. System.out was a stream to the console window. So what's a stream? A data structure that represents the flow of data between random access memory and external devices. And those external devices can be our input and output devices, keyboard and screen, for example. They could be data files. As a matter of fact, you can even have streams of data that's coming in from the internet or going out to the internet. And if we were to go deeper in this class, we might have done some sockets programming. We're not going to go do network kind of programming in this class, but it's certainly possible to do that. And in all of those cases, you're dealing with streams. So I think it would be interesting to try and remind ourselves from the documentation how to navigate our way through the documentation to find information about these classes, our file and our PrintWriter and the notion of streams, input and output streams as well. So let's go to the documentation. So here on Canvas, you'll notice that in the code examples of your Canvas course, there is a link to the Java 8 API documentation. So I'm going to click that. And we're seeing it here within Canvas, but I can just go outside of Canvas, get a bigger picture of it. So I'll click here. And remember, we have all of these packages and all of these classes. Let me take you quickly to the java.io package. I told you we're going to have to make use of this package, java.io. And packages will have classes, and they'll also have these things called interfaces. We won't worry about interfaces for now, but we'll talk about classes. And so there's file. Okay. There's also PrintWriter. And there's also this thing called print stream, which, as you can see, a print stream is a subclass of filter output stream, which itself is a subclass of output stream, which is a subclass of object. As we'll see later when we get deeper into object orientation. Object is kind of the granddaddy of all the classes in the Java class library. Any possible class that you can create is ultimately a subclass or a descendant class from object. Even if you don't really specify it, it still is. And we'll talk more about that later. Let's go back and look at java.lang and take a look again at the system class. And you can see that the system class has an in and an out. So there's system.in and there's system.out. And in is an input stream. So I can go to input stream right there and I can see, oh, that's also a class in the java.io package. And I go back. There's also out, which is the print stream. So those were the standard input and output stream. Notice the data type here, and also this word static, which is a modifier. And you'll notice that pretty much you see statics all the way down for system. There are some classes that are intended to be instantiated, and others that are not. And when you have a class that basically every property of that class, all of its member variables or fields, they're often called as well, and all of its methods have static as the modifier, there's no instantiating. You're not going to see any code that says something equals new system. Unlike, for example, string. Let's look at the string class. The string class, most of what the string class has is not static in front of it. All of these methods are not static methods. They are what are called instance methods. There is some static stuff in strings, as you can see, but a lot is not. So a string is meant to be instantiated. Another example would be a scanner that's meant to be instantiated. And you did create instances. A PrintWriter would be the same thing. These are meant to be instantiated, but system is not. And another example of a class that is not meant to be instantiated is math. If I go to math, you can see everything's got a static in front of it. And of course, your classes so far have had static because the one member of your class is the main method. And what is it? Public static void main. Another hint that a class is intended to be instantiated is the fact that such a class will have what's called a constructor. And a constructor is a special method. And the name of the constructor is exactly the same as the name of the class. And that's also something that we'll talk about later when we get into object orientation. So to get back to this notion of a stream, we are going to be making use of streams to be reading data in from files and writing data to files, just like we made use of streams to read from the keyboard and write to the screen. So here's a couple of examples from chapter 12 that we'll look at. This one called ReadData, and another one called ReadData. So here I am in NetBeans in the Liang examples, and in chapter 12, and we have ReadData here, and we have WriteData here. So here's the code for WriteData. And let me go ahead and just run this. Let me I'll go through the coding in a little bit. It's going to create a file called scores.txt. And that file is going to contain the names and numbers, as you can see with these prints here. This is a PrintWriter, and you can do print and print line, just like you can with other stream output stream kinds of things. You did print and print line with system.out, right? So let me run this. And it ran. And let me show you what it produced. I'm going to go into the folder. Here's where I have my Lang samples, and here is where and within that project, within this NetBeans project, there's the source file, and I've gone and navigated into there before. And within there, there's all these chapters and whatever. But in the root folder of the project, there's this scores.txt that just got created. And if I double click on it, you can see that that's the values that went into it. So that's what WriteData is doing. And if I run ReadData, it's going to read that same file. And it displays the results. So let's take a look at the code. So in the code for WriteData, here we can see we're instantiating a file object. Now you'll notice that I put the full package name here, java.io.file when declaring the variable, and also java.io.file when instantiated. And the reason that they did that was, I guess, as an alternative to actually importing the package. You'll note that there's no import statement here. If we had said import java.io.star or import java.io.file, then we wouldn't have to put all of this stuff in front of the name. And that's why I prefer to use imports. But I think the author of the textbook wanted to show that you can do it without an import, but you have to give it the full class name. So the full name of a class includes its package. And if you import the package, then you don't have to explicitly state the package. If you don't, then you do. Now, once in a while, and this is rare, but it could happen, you might have two classes of the same name in different packages. And if you are importing both of those packages, you need to actually be explicit about it. It will be ambiguous otherwise. So here's our instantiation of the file. And as you can see, by default, NetBeans is going to put the file directly in the project folder. We saw that if we wanted it to go to a specific location, we'd have to give it the full path. You'll notice that it's also testing to see if the file already exists. If it does, then it's not going to write to that file. Notice what it says. If the file exists, so exists is a method of the file class. If it exists, it's going to print a message saying it already exists. And this exit is just basically saying, I'm done, I'm going to terminate. And 0 is I'm terminating, it's okay. You can have other kinds of statuses as well. And then once you have created this file, the file itself gets passed as an argument to the PrintWriter constructor. So file right here was the name of the constructor when we instantiated a file. We invoked the constructor, and similarly, PrintWriter is the name of the constructor. And what do we pass? We pass this file, so that the PrintWriter is writing to that file. We could have passed other things other than files, and the PrintWriter could be writing to other things because it's just writing through streams. And then same thing, system.out.println, system.out.print, same kind of things that you're doing, but this time to a file, and then ultimately closing. And for the read, again, they chose not to do an import, but notice that they did import java.util.scanner, so I didn't have to say java.util.scanner input equals new java.util.scanner. That's the advantage of importing. But in all these cases, we're instantiating. We're instantiating a scanner object by invoking the scanner constructor. We're instantiating a file object by invoking the file constructor. So this time, we created a file, scores.txt, which, by the way, is kind of assuming that that file exists, because if it didn't, there would be an error. Notice here we have this main throws an exception. Let's see if we have the same thing here. Yes, we do. Main throws an exception. You try to do some things that will generate exceptions, and you have to handle it some way. And in this case, what is main doing? Main is just passing the buck. So it's still, the exception gets caught by the virtual machine. We'll see what happens when something like that occurs. You'll probably run into exceptions before yourself. So we are instantiating a file, and we are passing that file to the scanner constructor. Now, what did we use to pass to the scanner constructor? System.in. System.in is an input stream. This file is also an input stream. We were reading from this file. And so whatever you can do with scanner, using nextInt, all the scanner stuff that you learned about before that you can do from the keyboard, you can also do from the file. And this is a nice little Boolean method, hasNext. Once you've reached the end of your file, then hasNext is going to fail. So basically it's sequentially reading through the file and reading each subsequent little token from that file and putting it into the variables, and so that's what we have as a result of that. So let's look a little bit more at what might happen, for example, if we have an error here. I'm going to go in here and I'm going to delete the scores file, so it no longer exists, and then I'm going to try and read. So here I am, I'm going to try to run it. And lo and behold, we got an exception. And where did that exception take place? Well, it took place in some methods way up in the library, in the API. But where did it start in my code? Right here, when I tried to instantiate a scanner with this file. And let's try and debug it and see what happens. I'm going to put a breakpoint right here. And I'm going to go ahead and debug it. And what does file have? File is scores.txt. I mean, that's the path. But yet we have this error. And basically, what that means is the file's not there. Now, that's not a very elegant way, I will say, of handling an error. And that's why we're going to want to talk about exception handling. As I said, main is just passing the buck. And that's not what we want to do. What we want to do is we want to catch exceptions, and we want to deal with them in a graceful manner. I want to do one more example. And this is an example that I wrote, so I've provided it for you. Let's download it from Canvas. So in the modules on Canvas, in the code examples, here's something called text file examples. So I'm going to download that. And I'll go ahead and put that into my source directory in the Liang project folder. And I should see it therefore here. And let me open it up. And this is the file, the Java file we're going to look at, TextFileIOWithScanner. There's another one also that uses string tokenizer, and I don't, like I said, I'm not really going to focus on string tokenizers, although string tokenizers definitely come in handy from time to time, but I'm not going to focus on that now. I'll open this. And you'll notice that it's going to read a file called number file. Here's where I've got the scanner that's reading that file. And it's going to write to a file called output file. And number file I actually had included in the package. So let me go into the folder and go into this text file examples. And I'm going to take number file. I'm just going to put it into the root folder of the Liang samples because, as I said, by default, NetBeans is going to assume a file is in its own project folder and the root of its own project folder unless you specify otherwise. So here's this file called number file, and if I open it up, you can see it has these different lines, and each line is starting with a letter, and then it's reading numbers. And the different lines have different numbers of numbers. And what the output is supposed to be, and let me go to the PowerPoint here. Oops. what the output is going to be is basically a summation of these numbers with the result. And so we're reading this file and we're producing this output. That's the idea behind this code. So if I go to here, and I'm just going to go ahead and run it. And when I ran it, it produced some output. It did produce the output in the console window, because it did some system.out.prints and print lines, as we'll see. But it also created this new file called outFile, and we open it up and we can see those results as well. So let's see how this code worked. So on the slides, I'll step you through some of the basic elements of this. Here we are instantiating a file object, an NBR file, and we are making a scanner for that, so that's our input file. And similarly an output file, so we're making a PrintWriter for that. And then I basically have a nested loop happening here. And my outer loop is looping as long as there's something left to read. And so what do I do if there's something left to read? I actually read something. That's going to be the label. That's going to be the A. And I print it out. And not only do I print it to the console window, but I also print it out to the file via this PrintWriter. And then I have an inner loop. And that inner loop is looping as long as there's something left that is actually a double. So what this was saying here, as long as there's anything left, has next. But this is saying not only does there have to be something left, but that whatever that thing that's left has to be a double. So let's take a look and see what that would mean in terms of the data. So here was this NBR file, the input file. And this outer loop keeps looping as long as there's something left. So as long as there's something left, it's going to keep looping. And the first time it read next, which went into the label. So that was this thing right here. By the way, how does it know what's the next thing to read? How does it know when to stop? It knows when to stop because there's delimiter. The spaces are delimiters. Tabs would also work as delimiters as well. You can actually specify custom delimiters if you want as well. So, but by default, spaces are delimiters. So this first scanner.next took an A and put it into label, and then those things got printed out. Printed out to the screen and printed out to the output file. And now we enter this loop. Well, is the next thing that we see a double? Well, this was the last thing that we read, and yes, this next thing will qualify as a double. It's only an integer, but an integer can be automatically converted to a double. I think you've seen that before. So yes, it's numeric. It satisfies the criteria for being read as a double. So it will actually be read as, when we read next double, it will actually be read as a double, and it'll be a 1.0. That'll go into here. And it basically keeps doing that for this number, 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 for this number. And when it gets to there, after it's read the 7.5, this has next double is going to fail because the next thing to read is going to be the B. So that inner loop is going to terminate. Within this inner loop, what was happening? Well, I had this thing called operator that I started as a space, and then I'm kind of putting a plus in there each time so that I'm printing out something plus, something plus, something plus, and I'm also incrementing my total so that at the end of this inner loop, when I was just doing prints, I was not doing print lines. At the end of this loop, we're at the end of this line with all of these numbers, 1, plus 2, plus 3, plus 4, plus 5, etc., plus 7.5. and I've kept incrementing, I've kept summing the value into tote. At that point, I'm printing out the tote, and that's a print line. And that's why we're going to have the output that we see here. So this kind of illustrates that different lines can have different numbers of values if you want. And here's how we were able to distinguish when we wanted to end our inner loop. Another thing to consider here is we're using the exact same methods. System.out.print, PWriter.print, or print line. Exactly the same method. You can treat the PrintWriter exactly the same as you treat system.out. Important to either close, or at least there's something called flush, which guarantees that the result gets actually last little bit that might be held in a buffer gets written out. So best to just do a close for your PrintWriter when you're done using it. Okay, exception handling. We saw throwing of exceptions in the two examples from chapter 12. As I said, that's not really what I would consider to be elegant programming. We want to be able to catch the exceptions. And so here we see that happening in the code as well. So I have a try block and I have a catch block. And the try block is trying to do everything basically here. Anything that can generate an exception within here is going to be caught here. You can specify specific kinds of exceptions if you want to. There is a whole hierarchy of exception classes. The root of that hierarchy is the exception class. So all specific kinds of exceptions are descendants of exception. So for our purposes in this example, it's fine. We'll just catch a general exception, and we'll see this error right here. So let's try and do that. I'm going to try and run this without having the number file in there. So here I am. I'm going to go ahead and get rid of the number file. And then I'm going to go ahead and run it. And I get this nice little message here, instead of the ugly thing that happened as a result of throwing the exception. So exception handling is going to be an important part of your next assignment. And I think in general, you want to handle exceptions gracefully and not just throw them.